Good afternoon. So as Matt was indicating, I represent Netflix Engineering. And I think I need one of these. And what I'm going to be talking about this afternoon briefly is Netflix's content delivery network, which I'll explain what that is in a few minutes. So first of all, Netflix, from an IT infrastructure point of view, is an extensive user of public cloud services, and in particular, Amazon's AWS service. And we use that for our compute tasks as part of the service, the website, our extensive personalization, the client APIs that Netflix clients, the video clients are talking to, and things like our video encoding. And we publicly talk about that quite a lot. We have a large amount of engineering resource around making our public cloud initiative effective and efficient. And I'm not going to talk about any of that today. I'm going to talk about the other part of Netflix infrastructure, which is global CDN, and a number of different features about how we build the hardware and software that makes that global CDN operate. And basically 100% of video streaming, so that's HTTP web delivery of video chunks to Netflix players for our subscriber base around the world, is delivered off our platform. And we have a dedicated set of hardware we've built, which I'll talk about, and they're distributed in a number of key hyper-connected locations in the markets we operate, and also embedded within internet service providers. And really the reason that we do our content delivery very different from all our other compute tasks is represented in this pie chart. And so that red chunk of a little more than a third represents the peak fixed line broadband access in North America that is Netflix data versus all the rest of consumer internet. And this amount has been relatively stable for the last 2 or 3 years as our streaming services become very popular. And what it means from a content delivery point of view is we're a very large player in that space, and historically Netflix outsourced our content delivery to 3 large content delivery networks that delivered the content for us. But because of this large fractional share, it made sense to us in a number of different ways of sort of scaling and efficiency to take that on board ourselves. And whereas with Amazon, while we do a lot of compute tasks, we're a very small compute customer compared with global public cloud users. On the content delivery side, you can see we're a very large player. So a little bit of a background about what content delivery networks are in case people aren't clear. It's basically a concept that originated in the late 90s. And there's 2 different parts to running a content delivery network. One is to distribute web assets in multiple places, typically sort of deeper within networks. And that allows content to be downloaded by individuals in a more efficient way than traversing large amounts of network. And large amounts of network typically saves a large amount of network cost as a result of that. And the other important component to run a content delivery network is this concept of intelligently mapping an end user to the appropriate cache where a copy of the content is. And I'll talk a little bit more about how we do that in a minute. But the end result of using a content delivery network is you get a large amount of scalability, you can save end-to-end cost, and you can also improve latency. And so if you think about a web page loading, if it has to load from the US to Europe, there's more latency involved than if it can be loaded from a server within the same metro region. For video streaming like Netflix does, it's less of a concern. The majority of our users are watching TV or movie length content from 20 minutes to a couple of hours. And that initial latency is less important, but there are other use cases with content delivery networks where latency is the most important aspect of it. And then commercially, in case you've come across these names before, there's 3 large vendors. There's a bunch more as well, Akamai Level 3 and Limelight. And they were all vendors Netflix had used historically. I should also point out that at this point, the project's been operating for a little over 2 years, and we have a team of about 40 people that work on this project. It went from taking no traffic to taking 100% of traffic at the beginning of this year. And those 40 people are approximately distributed in terms of about half of them work on software, software engineers, about a quarter of them are network engineers and architects, and about a quarter of them are operations staff. So I probably should have started to check with the room to make sure people knew what Netflix was. We're a subscription video on demand service. We offer a large library of material both from movies and television. And we operate over a large set of devices, connected devices, from game consoles, smart TVs, tablets, mobile phones, set-top boxes, and a number of other devices. Probably more than 1,000 different device types. As part of the service, we have an extensive personalized experience. And as a subscription service, everyone who logs in from a client, they'll get to see a personalized set of movie recommendations based on what they've watched historically and the catalog, and we try and mesh that together and offer them something that is sort of compelling and will delight them that evening. We also have special sections for kids content, and being advertising free, it's a very popular part of our service. We now operate in both North and South America and parts of Western Europe, including Finland, where this screenshot comes from. And we're expanding our global footprint in the coming years. So now let me tell you a little bit more about how we do video streaming. And in particular, we use an adaptive bitrate technique where basically we have intelligent clients that are actually able to work out, based on the size of the buffer of content that they're pulling down, what is the appropriate network connectivity that they have that will allow them to give us, to play out the best quality of experience. And that quality of experience can be really summarized as 2 different components. One is a high bit rate, or the highest bit rate that they can manage, which obviously then means a nice clear picture and sound. But also we want to avoid, in as many cases as possible, any rebuffering event, because that gives obviously disruption to viewing and a bad user experience. And so the clients themselves, whether they're operating on a PC, whether they're operating on a game console, on a smart TV, they're intelligently, constantly polling the bitrate that they're able to maintain to fill that buffer and to play that content out in the best possible way. And so as part of our mechanism, historically, when we used third-party CDNs, we built an extensive control system that basically did that second component of what CDNs do as an overlay over the CDN networks we used, and would use real-time metrics coming back from clients and other types of rules about errors and the quality of links to choose different CDNs. And so when we flipped to change direction and build our own infrastructure, that component was already somewhat in place, and instead of using third-party CDNs, we now use our own servers in different hierarchies within the network of Netflix equipment. And so this control plane, it's another cloud service, does a number of things already with clients. It authenticates the particular device and the subscriber. It hands back the dynamic user interface that you saw a couple of screens ago. And it now also does the selection of, hey, this particular client is in this part of a network, and the ideal server that has the video content that they just want to watch right now is here, and then there's a backup server and another server beyond that, so the client has some ability to have some resilience without having to go back and basically restart the process again. So this OpenConnect CDN that we've built, content delivery in general and those third-party services are general purpose services that offer the ability and the infrastructure for large global news websites, software downloads, gaming updates, video services, any number of different types of content. But the OpenConnect CDN for Netflix is just doing one thing. We just do video delivery, and we're able to optimize an awful lot of aspects of that, and I'll show you more once we get to the hardware around that. The other interesting thing is, for a global CDN that operates as a third party, typically you use various tricks to make web browsers go to the right caching network or right cache within the network. And in the Netflix case, we don't need to do that. We already know exactly where the end user clients are, and so we can do that mapping much more directly. I think there's a number of aspects around the optimization of the delivery that we also do, because we now own basically software at both ends of the stack. We own software that's running on the client, we own software that's running on the server, and there's various aspects of TCP optimization that we can do there as well. And the final thing I want to talk about from a system point of view is we proactively cache the content. And why do we do that? The content is a very deeply viewed and relatively large subscription library of video content. And so this is somewhat confusing log plot with percentage of delivery offload, so the number of bits that originate from certain bits of content, versus the size of the library. And you can see you really have to go out to more than 10% of the library to get 75, 80% offload. And when I tell you that the library size is more than a petabyte, it means that to get that 75 or 80% offload, you need more than 100 terabytes in a server or in an appliance to be able to offload that. And you'll see that makes a pretty simplistic set of design choices at that point. So in terms of why we proactively cache, the other interesting aspect of the library is we don't have a huge amount of popular content that totally dominates the viewing. So there are transactional video on demand services that highlight on their homepage, the day and date releases that are simultaneous with DVD releases. There's an awful lot of advertising around those. And in those type of services, you get a large amount of viewing of a very small amount of titles. In our case, as that previous graph was showing, we have this deeper catalog, and the best way to get statistics about what's statistically most likely to be watched, and therefore the best offload from a particular embedded device, is using some global statistics. And so we use that global measure of usage on a daily basis, and then we pre-populate caches in that sort of off-peak period, sometime after midnight and sort of before lunchtime, where people are still watching Netflix, but nowhere near as often as they do during the afternoon and the evenings. So let me tell you a little bit about the appliances themselves, and then I'm going to leave 10 minutes at the end, and very happy to answer some questions. The way we think about the hardware we build is we use commodity PC server hardware, and because of that, we typically do annual refreshes due to storage, network, and CPU vendor roadmap changes. We use a custom system configuration. I'll show you some pictures of why we do that in a minute. And we basically have two different flavors or types of system, a hard drive heavy unit and now a flash heavy unit. And they have two different use cases, and I'll take you through both of them. So the first is the the hard drive heavy unit, which is storage dense. I was telling you earlier that we need more than 100 terabytes in the single unit to get that 75 to 80% offload to make it a really compelling device. And the way we do that today is we have a chassis that has 36 3.5-inch drives in a very small box as servers go. It's a 4U, so it's a little over half a foot high. It's only 2 foot deep. And basically, it's a life support system for a bunch of hard drives and a network port. And so it uses a relatively small amount of power. It's dominated by the hard drives. We have some commodity Supermicro board, low power Intel CPU, a bunch of memory, and then a multi-port network interface where we're basically able to sustain close to the maximum throughput of all the drives all at the same time out of a couple of 10 gig links and being able to therefore stream between 10 and 20,000 simultaneous Netflix streams on a single device. So this is what the box looks like. The reason we went for a commodity design here on the chassis, and this particular box is made by Sam Mina, is we didn't, if you look at high storage density servers in the general marketplace, they're typically for a different sort of use case where the data on them is very important and they're hot swappable and basically field serviceable. In our scenario, while we think our movies are important, they're always copies of a movie we've got multiple copies of elsewhere, and you're not going to have to go out and go through a large process trying to get that off tape or anything. We've got it on other hard drives and other systems. So we operate the system with a fail-in-place methodology, and in particular, because of that, there's no hot swapping, and we can fit the drives in more efficiently that way as well, and have very low vibration. But it's still very important for us, and we see probably a 10 to 20% improvement in the total usage of power within the server for a very well-designed chassis versus a not-so-well-designed chassis. And a lot of that is around being able to avoid any hotspots within the drives. Then you don't have to run the fans so high to avoid the hotspots overheating, and because of that, you get added benefit also that the fans aren't running so high, you don't get so much vibration. It's all general goodness. It doesn't sound like a jet engine as well. Let me quickly take you through the other device, which is a flash optimized server. This is very different, and we can only use it in a number of very specialized cases because flash is still a lot more expensive from a storage point of view, even though we buy the cheapest commodity flash we can, which is in 2.5-inch form factor SSDs. We currently use the 1 terabyte Micron unit, and we put that in a commodity one-use chassis, but with 14 drives, we get less than 1/10 of the storage of the hard drive unit that I just talked about. That hard drive unit can hold obviously a much larger catalog, but the optimization around the flash-only unit is at locations where we can justify and have enough traffic, so more than a terabit of egress, then we can put whole racks of these flash units, and in aggregate, the amount of storage that they hold is enough to have a compelling amount of the library. So in about 10 to 15 locations, we have a large set of racks of flash-only equipment, and all our other locations, all our embedded sites, the hard drive focused unit that I showed earlier. A bunch of other similarities. The advantage with the 1U unit is we don't have to do any custom chassis work. It's an off-the-shelf chassis, has AC/DC options. In this case, we use a more powerful processor because otherwise we're CPU bound, because the I/O that we get off the flash devices operates more efficiently for us, and we put as much memory as we can in that device. I'm going to quickly talk through the system stack, but basically I'm going to get to questions at this point. We have what we call like a firmware image, and that's the way we operate the caching network. So instead of running a base OS and then some applications and configurations over the top of that, we actually roll those all together and run it much more like a consumer electronics device, where we roll out a particular version of all three of those combined as a single monolithic package. And that means we know the state of the network in a very precise way. We have a very simplistic application. It's a single-use content delivery network, so we don't have to run different things on different servers, and this allows us that discipline to do that. And then, as I was saying before, we run a control plane in Amazon's cloud that rendezvous the clients at our subscribers' homes to particular caches, and operates also a health check to make sure all the caches are healthy and aren't overloaded, etc. Just briefly, we extensively leverage open source for our firmware. The operating system is FreeBSD, and we have a number of key contributors of that community that are part of our engineering staff, and that allows us extensive customized support for our storage and network drivers. And then on the application side, we use the Nginx web server, a BGP routing daemon called Bird, and a bunch of custom software to pull that together. I have a little over 10 minutes left, so I'm going to ask for questions. If people could go to microphones beforehand so everyone in the room could hear, that would be great.
David, good afternoon. Martin McCarthy, Chairman of the Uptime Institute, and thank you for a great presentation.
Sure.
As we prepared for this, I know that there was a lot of interest in your talk, and I have been asked to actually, on behalf of the entire audience, ask the most pressing question. When will the next season of House of Cards be released?
I believe it was announced that there was going to be a third season. I'm guessing it'll be in the new year. I'm afraid you'll have to wait that long. The problem with the ability of Netflix to put all of one season at once is our true fans watch it within the first 24 hours. And they've got to wait 364 days for the next season to show up. Question down the front.
James Nikolai with IDG. Can you give us some more idea of the scale of the operation, like how much storage you have in the network or how many of those 4U boxes? And can you say a little bit more about how you do the upgrades once a year? That sounds like a lot of manual work to go out and upgrade all those.
Sure, let me tackle the second one first. And when I say upgrades, I don't mean we go and replace all existing infrastructure. I mean basically we refresh, so all new infrastructure going out at that point would be the new revision. And we have an expected service life of 3 to 4 years, which we think is sort of typical. And beyond that, the economics of maintaining the old system versus the bang for the buck of putting in a new one, we'll do a swap at that point. I talked a little bit about the fail in place. What we like to do is sort of do an advanced RMA. So in the facilities that have the box, if there's a failure that we can't deal with in software, we'll ship a new server out, and then the site can use the same box to ship the other one back to our system integrator, and they can do some troubleshooting on it. The other aspect that we try and do is we pre-populate content on the box before we ship it, because otherwise you can imagine even with fast network connection, it takes a while to fill 100 to 200 terabytes of data of movie content over the network, and so we want the device to be as efficient as possible on day one, and so we pre-populate it. Remind me again what the first question was again? Sure. So we have around 20 different peering locations that we use, and then many tens of ISP partners that also have equipment within their networks. And so overall, we have more than 1,000 devices.
Hi, Lilia Severina, Uptime Institute.
Yes.
I just wanted to understand better the architecture.
Sure.
So you have content stored on your servers in a central data center, potentially third party, I'm guessing. And then you have your own CDN network as well as third party networks like level 3 Akamai that you rely on. And then you rely on their edge cache to distribute. Is that right? Or?
So if we back up, the original content comes from our studio partners and goes into the Amazon cloud storage. Mm-hmm. It gets encoded into a Netflix-ready format and then gets distributed onto the Netflix CDN. We don't use third-party CDNs anymore. But you could think of our caching network, which I showed you examples of the hardware, as equivalent to an Akamai.
And why did you make that decision? Is it cheaper? Because presumably those three compete, so they could offer services at a pretty good price, I'm guessing.
There is some competition in that market. What we found, though, is at the scale we were at when we represent a third of the downstream traffic for these large consumer ISPs, it's better to have a direct relationship with the ISP rather than have multiple third parties that are involved in a much more complicated negotiation around connectivity. And also there's just sort of vertical scaling advantages where at the scale for content delivery where we were probably one of the largest, if not the largest, by volume customer of each of those 3 large CDNs. We probably didn't pay them the most out of all their customers, but we were giving them a large amount of bits. If you bring all those 3 together, it's a very large amount of traffic, and there's a bunch of optimizations because, as I was saying before, the equipment is built just to efficiently serve out our content. It doesn't have to serve out small images or other customers or all sorts of other complexity. So it can be very efficient that way.
Okay. Can I also ask about latency? You mentioned latency. Do you have any sort of numbers around what kind of latency you are looking for typically?
Sure. So latency is important from a nice user interface point of view, and we keep a number of client metrics. The most important would be the play delay. So when someone's looking through a set of titles and they decide to press play on an episode of House of Cards, at that point we want it to be as immediate experience as possible. And so to reduce network latency there, that's part of that experience. There's a number of other things going on in the background as well, though. We have DRM'd content, we have to get licenses, we have to decrypt that and set up that whole session on the client. So there's a whole bunch of work involved beyond just the network to make that experience as sort of snappy as possible. Question down here? No, sorry.
Hi, Leonard Ruff. Quick question, as your streaming capability has increased and that service has become more and more popular,
yes,
how has that affected I guess you would call it your traditional business of sending out DVDs in the mail, and what's the future?
Sure. So the future, and this is because I work on the streaming side, is 100% streaming. But it's also, if you look at the future expansion of the company beyond the US, we've never shipped a DVD outside the US. So, 3 years ago or more, we launched in Canada. Since then, through Latin America, through Europe, we never had a side-by-side DVD service there. And here in the US, streaming is by far larger. So there's many more people in the US that have used Netflix as a streaming service than as a DVD service. I think my time is up. Perhaps one more question? I'll let someone decide. Yep.
What was the hardest part of designing and building and running your own CDN?
I think the initial decision, once we decided to do it, beyond all the regular teething problems of building up a team, was we got super excited that we were able to build these high storage devices. And then we had some supply chain issues where there was extensive flooding of hard drive manufacturers in Southeast Asia. And we couldn't buy a hard drive to save ourselves, right? We had colleagues in other industries going to Costco and just buying hard drives off shelves and things. And so we found a partner in HGST for our hard drives who was able to give us a direct and consistent supply chain of those devices. So from a hardware point of view, that was certainly the most exciting time, and that was within the first few months of the project. And so I wouldn't say it derailed it, but it was problematic at one point. It was like, how are we going to source these? Thank you very much.